For number 17, we see a cylinder with a volume of 128 pi. Notice the pi is with that. So when we set up our formula, pi is the volume. We're actually looking for the diameter. X looks like it's a distance all the way across the circle. We're going to have to calculate the radius first. So we're going to divide by 8 pi. So the 8's cross out and the pi's cross out. So the pi's cross out. 8 goes in there one time with 4 left over. So 16 equals r squared. So when you take the square root of that, you get 4. And the diameter equals 2 times r, which equals 8. These are inches. It's not cubed, it's not squared, because this is a length, this is a diameter. Number 21, we know we're working with a cylinder. We're looking for the height. If we know the radius is 4 and the volume is 64 pi. Well, the cylinder looks like this. We have our formula. So we know that the volume is 64 pi. Notice that the pi symbol is with this. Very important to keep it. We know what the radius is. The radius is 4 squared. What we don't know is h. So we're going to divide by 16 pi. So the 4 squared crosses out and the pi crosses out. So 16 goes into 64 4 times, because 16 plus 16 is 32. And 2 of those make 64. So your h would have to be 4. For number 22, we know we have a right prism. We know the bases are supposed to be right triangles. The volume is 96 inches cubed. We're trying to find the height. And remember, the height is a distance between the bases. So I've drawn some right triangles with side lengths of 3, 4, 5. The 5 isn't going to be overly used for this one, but we are going to figure out the area of the triangle. So to calculate the volume, that is base times height, where this capital B is half of 3 times 4. So that's going to be 12. Take half of 12, which is 6. So these are all inches. So this is inches squared, because it's the area of the triangle. Now we take that area of the triangle and we multiply it by h. And that should equal our volume, where the volume equals 6, because that's our B, times h. The volume was 96. So we're going to divide by 6. 6 goes into 9 once with 3 left over. Goes into 36 6 times. So the height would have to be 16. So we found the area, and we use that in the formula to calculate the volume of a right prism. For number 23, we're working with a cylinder. We know what the height is, we know what the volume is. We're ultimately looking for the diameter. Well, to find the diameter, we need to know what the radius is. So we know that the volume is 1005.5, and so we need to figure out the radius so we can calculate the diameter. But we know the height is 8. So volume equals pi r squared times h. So we plug in our numbers. So we're going to divide by 8. And that's going to leave us pi r squared on one side and 125.69 on the other. Divide by pi. That'll leave us 40.007 or 8 equals r squared. When we take the square root of that amount, we get 6.33 for r. So the diameter equals 2 times r. So we times that by 2 to get 12.65. And these are centimeters. Number 24, we have an oblique rectangular prism. So we need to know the area of the base, and then we times that to the area of the height. What's lucky for us here is we actually know what the height is. We don't have to do any calculations to figure out the height. The height is not a slanted side. You got to be sure if they give you lengths of a slanted side that you're sure that you end up using the value of the height. So the base is 4 times 7, and then we times it by the height, which is 6. We get 168 inches cubed. Next, we're looking for an oblique, or working with an oblique cylinder. This cylinder is slanted to the side. The height of this cylinder is 14. It's not this slanted side. The radius is 8. So we use the volume that equals pi r squared times h. So that's going to give us 64, 8 squared is 64, pi times 14. So 14 times 64 is 896 pi. That would be our exact answer. But if we're supposed to round this to the nearest 2 decimal spots, nearest hundredth, the volume is 2,814.87. These are feet. Volume is cubed. For number 26, we're working with an oblique cylinder. It's slanted to the side at a 60-degree angle. We know the slant height, but we don't know the actual height. And that's the actual height that we need to know. So we're going to take this right triangle. We know that with a 30, 60, 90 triangle, the hypotenuse is the short leg times 2. Well, with our 60-degree angle, we have a slant, which would be our hypotenuse, of 18. We're going to divide by 2 to figure out that 9 is the short side. And then the long side is the short times root 3. So the long side is 9 root 3. So that's our height. So the volume is going to be pi r squared times the height. Well, our r value is half the diameter, so it's 6 times 9 root 3. Six and 9, 6 squared, right? So 36 times 9 is 324 pi root 3. These are meters cubed. To be an exact answer, you would leave it in this format. .324, which is the 36 squared times 9. Nope, sorry. 6 squared times 9 times the pi times the square root of 3 that would be rounded to the nearest hundredth like they're asking for. For number 30, we're working with this blue hole. It's 1,000 feet wide, it's 400 feet deep, it's a cylinder. So we're going to use pi r squared times h. We're looking for the volume. So the r, if it's 1,000 feet wide, then I know it's 500 for the radius. And when we take our 500 and square it, 5 times 5 is 25. Times that by 400. And we get 100. You get 100 million times pi. Then we times that by pi. So we get quite a bit, pretty big volume. And to figure out how many gallons there are, we take this number and we divide it by 7.48, because there's 1 cubic foot has 7.48 gallons in it. That's a lot of gallons. For number 31, we have a cylinder with a circumference that equals 10 feet. So if C equals 2 pi r, 10 equals 2 pi r, then we know that our r value is going to be 1.59, and we know that the height is 20. So if we take our number and square it, times that by 20, and times that by pi, that's the volume. For number 32, essentially we have this cylinder. It's made by spinning a card that has a height of 5 and a radius of 3. So the volume equals pi r squared times 5. 9 times 5 is 45 pi, and these are inches, so it's inches cubed. Or is it going to be more to spin it the other way, where the radius is 5 and the height is 3? We're looking for the larger volume. 25 times 3 is 75. So you get your larger volume when you spin it horizontally.